Welcome to this E3SM tutorial on MPAS-Analysis. My name is Zyler Asa Davis, and I'm from Los Alamos National Laboratory. And I'll just be teaching you how to set up and run MPAS-Analysis today. If you don't know anything about MPAS-Analysis, you might benefit from looking at this introductory video that I'll include a link to at the bottom of this video. Or you can browse through the documentation on MPAS-Analysis. And specifically, we have a long list of the analysis tasks that are available, and so you can kind of see what the different options are for different types of analysis that you can run. So each of these will include a little bit about how to configure it, but also some example output so you can see what you might be able to produce. So I won't get into that in too much detail, but I do want to introduce MPAS-Analysis a little bit. So MPAS stands for the Model for Prediction Across Scales, and this is a framework for creating Earth system components such as ocean, sea ice, land ice, and atmosphere. And it's specifically set up for variable resolution components on unstructured grids. This lets you put resolution maybe where you need it, coastlines or areas of interest or specific regions of the globe. And because of this unstructured nature of the meshes and the variable resolution, we needed a new software. The existing sort of ocean and sea ice analysis software is specifically designed for components that are on regularly spaced grids. So that's where MPAS-Analysis comes in. It's basically a new analysis software for specifically for MPAS components. So I'll be walking you through that a little bit. So one thing to know about MPAS-Analysis is the easiest way to use it is as a Conda package. So you can download the software, but even if you download the software directly from the GitHub page, you're going to need to be able to set it up in a Conda environment because all of the dependencies are Conda packages. And in this case, we're just going to install MPAS-Analysis itself as a Conda package, meaning we'll get the latest release version. And so I'll walk you through both how to install and set up a Conda environment and then installing MPAS-Analysis itself. And so that's where we'll get started. So the steps I'll go through are setting up a Conda environment, downloading the observations that are needed to run MPAS-Analysis. We'll download an example E3SM run, a fairly small coarse resolution one. We'll configure MPAS-Analysis, which means setting up a configuration file with all of the settings that we need for our specific run. We'll run MPAS-Analysis, which is probably the easiest part of all of this. We'll take a look at some of the example output, and then I'll go through just some very basic ideas of how you might troubleshoot if you run into problems with MPAS-Analysis. You'll probably have to get in touch with us if you get into any serious trouble, but at least some basics. Okay, so let's get started with installing Miniconda. So if you already have Anaconda installed or Miniconda, then you can probably skip this step. But I just wanted to make sure that everybody really starts from absolutely nothing and can get set up. So in my case, I have an empty directory here that I'm going to be working in. And the first thing I'm going to do is download Miniconda 3. So Miniconda 3 is for Python 3. We don't support Windows, but we do support Mac OS or Linux. And in my case, I'm running Linux, and I will download the very latest installer for Linux for Python 3.8. So in my case, I'm going to just copy the link and do wget on that link. You can just download it however you would normally do so, but for me, that's the easiest way to get it in the folder I want. Okay, so that's downloading Miniconda. The next thing I'm going to do is just install Miniconda, and there are a few nuances here that I will walk you through. Okay, so we're going to have to go through the license agreement. That's pretty fast. Read through it if you want, then agree to it. Hopefully you'll be able to install in the default location. But if, like me, you already have Miniconda installed somewhere on your machine and you want to do a fresh install, you might want to give it a different directory. So that's the case for me. So I'm going to actually put it in this tutorial directory where I'm working. So just give me a second on that. Okay, so I'm going to install into this new directory. And that means I have to keep in mind this directory where I installed, because I'll have to change a couple of paths later on in the tutorial. Okay. The other thing I'm not going to do that you might want to do is tell it to go ahead and change my initialization file, my bash rc, so that miniconda loads by default. So I'm going to say no here. You might want to say yes. You might want to just have miniconda go ahead and set up every time you open a new terminal. And if you say yes there, then all you'd have to do is open a new terminal and you'd be good to go. In my case, I said no because I already have a different miniconda that launches every time I open a new terminal. And in order to get this one, I'm going to have to source a special file. So I give you the default path here. In my case, I installed it somewhere slightly different, so I'm going to just have to include that different path. And I just source this file. So within the miniconda 3 directory that I just installed to, it's the etc profile.d / in my case conda.sh, because I'm running in bash. If you're running in C shell or T shell, it would be CSH instead of SH. It's the only main difference. So that's the path you have to remember just to be able to source this file. And if you didn't tell it to initialize conda right on startup, you're going to have to source this file every time you want to access conda. So just keep that in mind. And I kind of repeat that once more in the tutorial. Okay, so we've got miniconda installed. Miniconda is just a really basic Python environment with a couple of other packages. Importantly, the tools for actually installing things from conda channels. Okay, the next thing we need is the Conda Forge channel. So I'm just going to quickly take you to the link for the Conda Forge channel so you can see basically this is a big channel with a bunch of sort of interoperable packages that are really useful. And I'm just going to follow the instructions from that site, which say first add the channel. So we're going to use conda config to add the channel. It's called Conda Forge. And then what we're going to do is make the order of channels strict. And in my case, I've already done this before, so it's telling me that Conda Forge was already a channel. And I've already also set channel priority to strict. But this is a good practice. It basically says that if a package is available on the Conda Forge channel, you're going to get it from there. Otherwise, there might be some chances that you get different packages from different channels and they might not work together. So that's why that's important. All right, so that's setting up the channel. The last thing we need to do, and this is pretty simple, is create an environment. So this is an environment separate from the base environment of this Conda installation that I've just done. And the environment is going to be called MPAS-Analysis. And into it, I'm going to install Python 3.8 and MPAS-Analysis as a package, and then all of the dependencies of MPAS-Analysis. So it'll figure that out automatically. And they'll come from the Conda Forge channel because I just set that up. Okay, so this is going to take a little time. As soon as I've said basically yes, start downloading and installing the packages, I'll pause the video because it's going to take a little time, and we'll come back in just a second. Okay, so I think the packages are most of the way downloaded. What I'm going to do is open a new terminal window and pretend like as soon as this package is done installing, I'm going to pretend like I'm starting over, because this is how you would basically start up when you're wanting to use MPAS-Analysis and open a new terminal and so on. So that means I'm going to source this same file as before. If you set up miniconda to initialize on startup, you're fine, but it doesn't hurt to do this. So I'm going to do this again. So the special directory I'm working in, source this file. I can go ahead and do that now, and then I'm just waiting for this to finish up. We'll just take a second. As soon as it's done, I'll be able to activate the environment with this command, conda activate MPAS-Analysis. And just a reminder, if you're using C shell or one of its derivatives, you need to use the CSH instead of the SH version of this script. Okay, good. So the environment's done installing. We've got all the packages. Now I'm going to activate the environment. All right, so now you should see MPAS-Analysis as part of your command prompt. Tells you you're in the MPAS-Analysis conda environment. Okay. The next thing we're ready to do is download the observations. I'm going to go ahead and get this started because it really takes some time, and then I'll explain some things about it as it's downloading. So it's just this command, download analysis data, and then you give it a path, -o, and then a path. And so I'm just going to call that diagnostics and put it in the directory I'm currently in. It can be anywhere you like. It could be on an external drive or something like that. So I'm just making sure I'm spelling it right. Looks okay. So this is going to take quite some time because it is downloading 45 gigabytes worth of observational data and related things like mapping files and region masks that are used by the analysis. And at the moment, we don't really have an alternative to downloading the full 45 gigabytes unless you want to do it manually. If 45 gigabytes is really more than you're up for, you should get in touch with us because we could make a special branch for you with just the analysis basically set up to just download the analysis that you need. But for now, for most of our applications, we kind of need the full set. So it's kind of worth, if you can do it, it's worth biting the bullet and downloading these 45 gigabytes. I think on my connection, that took a couple hours, so you should be prepared for that. And basically pause the tutorial here, let this data download, take a break, do something else, or let it go overnight if you need to, or whatever that takes. I should also note, though, that if you're on one of the E3SM supported machines, the data is actually already downloaded somewhere. And we'll go through how to configure the analysis, but basically you can use one of the example config files that we provide, and it'll show you where the diagnostics directory is. So I'm going to quickly show an example there. So if you go to the link that I just went to, which has example config files, you'll end up in the configs directory of MPAS-Analysis. And in there, there's a list of different supported machines or supported sort of supercomputing locations for E3SM. And if you have access to one of these supported machines, you can go into the appropriate directory. So I'm going to choose Cori from the NERSC facility, which is one of the ones that E3SM uses pretty often. And I'm just going to pick the very top example config file here. Any of them will, for this purpose, will show you the same thing. If you go down to the section called diagnostics, you'll see that the base directory is this path here. And that just tells you on NERSC, we already have the diagnostics downloaded to this directory. So you don't need to download them yourself. And in fact, you'll save yourself a lot of time and disk space if you don't, if you just use this path. So that's, again, if you're on one of the E3SM supported systems, that's the way to go. If you're on your laptop or your own cluster or that kind of thing, that's where you need to use this download analysis data. Okay. And then, yeah, one more thing. So I'd mentioned that we don't yet support downloading a subset of the data. What you could at least do is take a look at the full list of files that this package is going to download. So this is just the relative path of all of the files it's going to try to download. And you could choose a subset of these based on basically what files you discover are missing when you try to run the analysis, and just download the files you really need for the analysis you're after. But that's going to be a pretty tedious process. So I don't recommend that unless you really need to. One last thing is, here's a link to the diagnostic server where you would go about doing that manual download if you really wanted to. So this is basically what the script is pulling these different files from, these 45 gigabytes worth of files. Okay, so that's all I'm going to do for now. I'm going to let the analysis, let this command line tool download all of the data that's needed for analysis, and then I will resume the video once we're nearly done with that process. Okay, so I think the download is nearly complete. We'll see how this goes. One thing I wanted to mention is, since it is a pretty large download and it might get interrupted for various reasons, let's say your connection's a bit slow or you get disconnected or you just have to quit for a while, that's fine. This download tool will pick up where it left off in the sense that it will start over on the last incomplete file. So if it's sort of halfway through a giant file, that's going to be a little disappointing, but it at least won't download any files that are already complete. So that's the good news about it. You can run it multiple times and eventually it should download all of the data that's missing. A nice thing about that as well is if there are important files that get added in future releases of MPAS-Analysis, you can update your diagnostics directory just by running this tool again, and it will just update any missing files. So that can be pretty useful if just a few new analysis files have been added. You certainly don't have to download 45 gigabytes of data all over again. Okay, so I think this is going to take just a moment longer to finish up, but while that's happening, we can go ahead and get started downloading the ultra low resolution data that we're going to actually analyze. And so this link here is just to a tar file, so I'm going to go ahead and let that go. It's basically from the same server as the diagnostics data, but this is instead an example run, and it's just the ocean and sea ice output from that example run. So I'm going to go ahead and let that download as well. It's going to take 4 or 5 minutes, and I'm going to pause the video again because you don't want to watch my little download icon go. But basically, we're just about there. So as soon as the example data has been downloaded and all of the diagnostics observational input and related files are done, then we're basically ready to go, ready to start configuring MPAS-Analysis. Okay, so I think we're nearly done with both downloads at this point. The example E3SM run has just finished, and the analysis data should be done in just a moment. So I wanted to say just 1 or 2 quick words about this example output. So the run is a specific type of run. So it's a fully coupled run, and it is WC, meaning W cycle, which means it's a water cycle type run. That's one of the science campaigns of E3SM. And it's repeat 1850, meaning it's a pre-industrial simulation. Is at coarse atmosphere resolution called NE4, and at coarse ocean and sea ice resolution as well, the quasi-uniform 480 kilometer grid. Anvil just refers to one of the machines that we support for E3SM. Okay, so as soon as this download is finished, I'll create a directory just following the instructions here to put that data into, go into that directory, and then untar this file that I just downloaded that includes the ocean and sea ice output from this simulation. So we'll just give that 1 second. Once I have the analysis data available, then we'll start configuring MPAS-Analysis. So that's the main sort of trick of getting started with MPAS-Analysis. Okay, great, this download's finally finished. I'll follow these instructions first, and then we'll get to configuring. Okay, so we make a directory for the example output. We're going to go into that directory. We're going to untar the file from one directory up. And what you'll see as you untar is that it goes into basically two different directories. And I'll talk about these a little bit later on when we're configuring. But there's sort of an archive of some ice data, meaning sea ice, and some ocean data, OCN. And then there's, at the very bottom, there's going to be a restart file for the ice, a restart file for the for the ice, for the ocean, and then what are called name list files and streams files. And you don't really need to know what these are. They just tell MPAS-Analysis something about this run, something about the configuration of the run, and then something about how the output in these archived files is structured. So that's something that we have to use the config file to point MPAS-Analysis to where these files are located. So that's the main thing to just keep in mind is if you're looking at an E3SM run, you kind of have to track down these different types of files and make sure you're pointing the analysis to the right location for those files. All right, so that's the example run untarred, and go back up a directory. Okay, so this is what we've got. We've got our diagnostics, we've got our example run, we've got our installation of Miniconda that's going to include this environment for running MPAS-Analysis. We've already loaded that environment, so we're ready to run MPAS-Analysis when the time comes. The next thing we'll want to do is create a config file. And a config file is also sometimes called an INI file. It's a sort of pretty typical way of configuring software in Windows, Linux, Python, that kind of thing. So it has these sections, something like runs, something like execute. It has options in each section with an option name and then the value associated with that option. So that this is a typical set of sections in one of our config files. So that I obviously am not going to go into it, but there's a default config file and it has over 1,000 different config options. And that makes MPAS-Analysis very flexible, but it also means it can be pretty intimidating to try to figure out what just all of these options are. So like I said, not something I'm going to be able to get into in this tutorial, but you can go through the rest of the documentation if you're curious to find out what all of these things are for, if you want to configure specific plots to be more like you want them to look. And of course, if you have specific needs, you should get in touch with us. What I will work with is an example config file. And so right at the root directory, so I'm on our MPAS-Analysis GitHub page. And right at the root of that, there's a file called config.example. And I'm just literally going to copy and paste the contents of config.example into another file, which I'm going to just name something slightly different. So I'm going to call it myrun.cfg in my case. It doesn't really matter. You can name this file whatever you want. And I use Vim to edit stuff. What editor you choose to use is entirely up to you as well. So I'm going to then go through this example config file and tell you some options that you definitely have to change and some options that you might want to change. So this goes through the basic options that you definitely have to change, and we'll get to those just below. Okay, so in the run section, the option that you almost certainly want to change is the name of the run. And so in this case, rather than calling it something generic like my run, we're going to call it the sort of fairly general name of this run. So it tells us something about what it's covering and what resolution, and then it might be convenient to know what machine it was run on so you could track it down again if you needed to. Okay, so that's the run section. Don't worry about the rest of it for purposes of this tutorial. The execute section controls running in parallel. We're going to want to run in parallel, and my laptop can handle 4 parallel tasks or so. That's probably a good place to start. We found on supercomputing nodes that somewhere between 6 and 12 works pretty well. And then specifically for a tool called NCClimo, we're also going to want to run that one in parallel. And the way you select that is a little different. You have the option between serial thread parallelism called BCK, background parallelism kind of, and then MPI. And I definitely suggest the BCK option if you can. If you're running out of memory when you try to run the NC-CLIMO, you would want to cut back. Don't worry about the MPI tasks for now. All right, so that's that directory, that section rather. The next section is diagnostics. So all we have to do here is point to the diagnostics directory that we just downloaded. So for me, that's, and it needs to be an absolute path. So that's what it is in my case. Hopefully I haven't made any typos, but we'll come back to this and take a look if I happen to have somehow made a mistake there. So then the input data is also in this directory. So this is now looking at the input section. The input data means pointing to the E3SM run that we want to analyze. And so that's going to be the name of this run that we just downloaded. So I'm just going to take a look here. So this is the folder name that I gave it. And so here we go. So that's the path to the base of the analysis that we downloaded. The run directory, where the restart files are, that is just called run, so we can leave that one alone. But the ocean and sea ice data have been what we call short-term archived. They've been put in a separate directory and cleaned up a little bit. So we have to, rather than being in the run directory, which they would be right after an E3SM run, they are in a separate directory from short-term archiving. So we're gonna update that here. The name list files and the streams files are in the run directory, so we can leave this alone. And that's about all there is to that. The last thing we have to do is set the name of the mesh. And we know that from the name of the simulation itself. So if I scroll all the way back up to the name of the simulation, it is it includes this OQU480, and that tells you that it's the ocean and sea ice mesh at quasi-uniform 480 kilometer resolution. So it doesn't matter too much in this particular case, but it's always helpful to have the quote-unquote correct or the standard E3SM name for these meshes, because sometimes it means that you won't have to generate new mapping files and things like that for regridding data, that it's already available in the diagnostics directory. Okay, one more section that we need to configure. This is the output section. So this is where we're going to write out the analysis. So it's going to be, in my case, very similar. I'm going to go ahead and copy and paste this directory for the input. I'm going to call it almost the same thing, but I'm going to put it in an analysis subdirectory, and that's the only difference I'm going to make here. How you want to structure this for yourself, that's totally up to you. You might even, so some of my colleagues like to put the analysis within the run in an analysis directory inside. That's also totally fine. So under this base directory for the output, you'll get several subdirectories. And by default, one of those directories will be the HTML output that's considered the main output of MPAS-Analysis. And for this tutorial, we're just going to leave that alone. But if you're working on a system with a web portal, you might want to give the absolute path to someplace within that web portal so that the website basically already is all set to go online, and all you have to do is change permissions so it's world readable. So MPAS-Analysis doesn't try to do that for you. We want to make sure that you make that conscious decision to make your data public. But if you want to do that, change this HTML directory to be the web portal, and you'll be all set. The last flag in the output option, the last option in the output section is called generate, and it's a pretty complicated thing that lets you control what analysis you're generating and what you're not. And in this tutorial, we're not going to go into those details. It's just important to remember that there is a way to control which analysis tasks you choose to generate and which you don't, and it's worth going through the documentation to figure out how to do that. What we're going to leave it at is we're going to generate all of the analysis where the observations are public. In other words, where the observations got downloaded with the script that we ran before to download all of the observations. Okay, just 3 quick little sections more, which I combined all into one description here. So we write out climatologies, or we make plots of climatologies. So those would typically be maps of fields from E3SM. We also do time series, and we do a climate index called the El Nino 3.4 climate index. And in each of those cases, we just need to set the range of years that we'd like to look at. So for the climatology, we're going to do the last 3 years, years 3 to 5. This is just a 5-year short simulation. For the time series, we're going to do all 5 years, and for the index, the same, all 5 years. That's it. So for a really basic configuration of a run, those are all of the config options you need to worry about. Okay, so believe it or not, that's all there is. We are ready to run. So the next thing we're going to do is just copy and paste this very simple command. We're going to run the MPAS-Analysis command line tool and pass in the config file we just created. And that's really it. So if all goes well, we will see output just like here. And if all doesn't go well, we'll learn some troubleshooting. So we'll see what happens here. So MPAS-Analysis has a couple of different stages. So right now it's in what's called the setup stage. And you wouldn't know this running the code, but that setup stage includes things like checking to make sure the analysis, the E3SM simulation was run in a configuration that's consistent with the analysis that you requested. So maybe some of the analysis only works if certain features of the model are turned on, and it makes sure that those features are actually turned on. The analysis will still run, but certain tasks will sort of complain that they're not configured properly if that turns out to be the case. What it's doing right now is generating mapping files because it doesn't know this OQU 480 mesh yet. So it is generating mapping files that go from that mesh to some different comparison grids. So a standard global grid at 0.5 by 0.5 degrees, and then also a grid that's around Antarctica. And it also hasn't cached a mapping file for one of the sets of observations for eddy kinetic energy. So it's going ahead and noticing that that mapping file is missing and generating a mapping file for that purpose. We probably need to cache that mapping file. It's not an analysis that we do terribly frequently, so that's probably why it hasn't been included yet in the standard download. So the setup phase will take a little while. The next thing it'll go through is some setting up mapping for some transects for a Southern Ocean focused set of data called SAUCY. It's a state estimate of the ocean. And then it's going to do one more mapping file, and then setup will finally be finished. So that takes, in the example that I ran earlier, that takes about 3 minutes for the setup phase to finish. And then it will get to the run phase. And during the run phase, you really won't see much of what's going on. There will just be a progress bar that continues for, in this case, maybe 20 minutes. It depends on your system and how many tasks you're able to run in parallel and so on. So obviously, I'm going to pause the video once we get to this run phase and just let it do its thing, and then I'll get back to you once it's nearly done. Once the run phase is completed, if everything goes well, it'll point you to a place where you can find some log files that will describe all of the analysis that you ran. It'll tell you how long it took, and it'll tell you that there's a web page available for you to look at. And so we'll take a look at that, assuming all goes well. If it does not all go well, then that's where the troubleshooting section comes in. Before I pause for a moment, I'm just going to also point out that If you want to find out a little bit more about some of the options for this command line tool, MPAS-Analysis, you can just call --help on it or -h, and you'll get all of the different options. Just to let you know, you can list the available analysis tasks. You can plot some of the color bars, for example, that are available. There's various options there related to configuring which analysis to generate and a few other things like that. And for troubleshooting purposes, it's also useful. You can make sure there's more verbose output in certain circumstances. All right, so I will see you in just a bit. Okay, the analysis is just about done. Progress bar is humming along. So I'm going to go ahead and bring up the directory that we want to take a look at the HTML once it's produced in about 20 seconds or so. So I start off in this directory where I've been doing everything. I've got my input run, my output analysis, the diagnostics that we downloaded, the Conda environment. So I'm going to go into the analysis folder and into the directory specifically for the analysis for this run. And I'm going to see that there's an HTML directory. And now that the analysis just finished, and I'm seeing basically how long it took. So I think because of Zoom running to record this tutorial, it's a bit slower than normal. But it took about 26 minutes to do all of the analysis, and it's ended up in this folder. And so what you want is this index.html file within the HTML folder. So just double click that, and in my case, it comes up in Google Chrome. What you'll see is the that it's MPAS-Analysis diagnostics. You'll see the name of the run, whatever you gave it. The components, ocean and sea ice, and these are web pages you can click on, and we'll get to that in just a second. And then something called provenance, so basically keeping track of something about the run you did so it could be repeated if somebody wanted to. What version of MPAS-Analysis you used, and then what command you ran, and then the contents of the config file you used. And sometimes it's helpful to have the complete config file with all of the config options, including the default ones. So that's what this complete configuration file is. All right, so I'm not going to go through the complete output here. There's quite a bit of it, but there's a set of ocean output we'll glance through in just a moment. Then if you go back to the main page and pull it up, there will be a page of sea ice output. So there's less sea ice output. Let's do that one first. There's sea ice output for the northern hemisphere and for the southern hemisphere. So this is northern hemisphere, southern hemisphere. There is sea ice concentration, sea ice thickness, and then further down, there will be time series of sea ice area and sea ice volume for each hemisphere. This is a very coarse simulation. We wouldn't expect it to be physically realistic. If we actually pull up individual plots in these galleries, we'll see that they don't look fantastic. You can scroll through them with the arrow keys or the mouse or whatever is convenient for you. But that's just because it's a very coarse resolution. Okay, so that's the sea ice. And then in the ocean, there's just a large number of global plots. So mixed layer depth are the first ones, sea surface temperature, sea surface salinity, sea surface height, something about the kinetic energy, the eddy kinetic energy of the simulation. So at coarse resolution, not surprisingly, it's poor. The ocean heat content, a bunch of maps around Antarctica. I'm just going to scroll through those very quickly. So various ocean properties, including temperature, salinity, density, and velocity. Some global comparisons with various observational data sets, and also at various depths. So in the ocean especially, that can be important. So temperature, salinity. We also support plotting temperature against salinity, so what are called TS diagrams. That'll let you know whether the water masses in certain ocean regions are close to what they should be. So in this very coarse simulation, um, just over 5 years, we're not going to see much drift from the initial state of the model, so it looks pretty good. Later in a simulation, especially this course, they probably wouldn't continue to look so good. Time series of various things like ocean heat content and sea surface temperature. Meridional heat transport, so basically how heat is being transported north and south in the ocean. Something about the meridional overturning circulation. So again, this is not the right simulation to really look at these things in detail, but on a higher resolution simulation, you could take a look at the strength. You could take a look at the strength in a particular location as a function of time and see if it's increasing or decreasing, how it compares with observations. The El Nino index, 5 years is not long enough to get useful statistics, but on a longer run, you could definitely find out if the statistics are similar to observations. Then we have some transects of areas around Antarctica. I'm not going to go into those in any detail, and I think that's it. That's what the default analysis will plot. So going back to the tutorial, you'll be able to look at your analysis, and then if you like, you can compare it to the example output that I've put up on the web. And that's not going to look any different than what I just showed you, but just for comparison. So this is, as opposed to being on my own machine, this is the example analysis that I've gone ahead and hosted with the documentation. So you can take a look, make sure everything looks similar. It should basically look nearly identical. Okay, so then the last thing I want to do is a bit of troubleshooting. And in order to kind of get us started, I'm going to purposefully put a little typo into the config file. And that is, I'm going to name the diagnostics directory something wrong. So going down to the diagnostics area to the base directory, I'm going to pretend I called it diagnostic instead of diagnostics and see what happens. And I'm going to do one other thing, which is I'm going to add this purge flag, which means delete the analysis I just did and start over before running new analysis. So let's see how that goes. So I'm going to purge, and I have a typo. I'm expecting problems. So this is the purge process. It's deleting the contents of various directories, starting over. And then this is where I expect as setup runs, it's going to, there we go. So it's going to start doing some things that don't require the diagnostics output, but then it's going to run into lots of problems with different analysis. And it's not going to tell you very much about what went wrong. So I just killed the run with Control-C because I know that it didn't do what I expected. So it's just warning you that all of these different tasks failed. You're not going to be able to tell why they failed because we've got it running in quiet mode by default, and it's only going to tell you that they failed, not why. So that is why I have this verbose mode. So that's the next thing to try. There were errors during setup. So we're going to try verbose mode to find out a little bit more about maybe what's causing those errors. And so rerunning the analysis, we probably don't need to purge again because not much has happened since we purged before. Okay, now we're getting tons and tons of error messages. It's going to be kind of overwhelming, but we're just going to look at the last few and try to figure out what went wrong. Okay, so the very last set of error messages are just keyboard interrupt because I killed the analysis knowing that it wasn't very useful. But if I scroll up a bit, I see no such file or directory and some path. And it is specifically looking for something that's an observation. So that gives me a clue that I might have a typo in my diagnostics directory because it's not finding this. So maybe I would try to list this file to see if it actually exists. I would find out, no, it doesn't. I'd figure out that I had a typo. So that's one thing to look for. I'm not going to demonstrate it, but if you had errors in the forward run, they wouldn't come out until this progress bar started showing up. And then you would see that certain tasks did not complete successfully and that you should take a look at the log file associated with that task. And it'll give you the path to the log file. Even if you can't figure out what's wrong, go ahead and open that log file and include the contents of that log file if you can with an issue that you might post on our GitHub page. So I'm going to just show you, there's a link here to the issues section on our GitHub page. Here it is. You can just do new issue and get in touch with us and basically say, here's what's going wrong with my simulation. Can you help me out? The more information you can provide, the better, but the basics would be maybe your config file and whatever log file you can provide with what's going wrong, or the verbose output of setup if that's where things are going wrong. All right, so that's it. Please do get in touch, either if you run into trouble with MPAS-Analysis, if there are analysis tasks or other features that you'd like to see added. Thank you very much for participating in this tutorial. We'll see you next time.